Hello everyone. The size of this huge sales table is almost 10,000 rows, but all this data can be easily and clearly analyzed. You just need to convert it into charts and present it as a dashboard. By pressing special buttons, I can instantly display the information I'm interested in, and it's very convenient. Watching this video, you will learn how to independently create various dashboards and also discover some Excel workflow nuances that will take your skills to the next level. If this video seems too fast or slow to you, then you can easily choose the playback speed that suits you. And if you want to watch videos without sound, then just turn on subtitles. I wish you a pleasant viewing. So, let's get started. Currently, my working document consists of two sheets. The first sheet contains the large table I just showed you, and the second sheet contains a small table, the data from which will also be used in creating the dashboard. Yes, I will teach you how to filter two completely different tables at the same time, but you will learn about that a little later. For now, I would like to show you how to properly prepare the foundation for a dashboard. By the way, you can download the Excel document with the source data from the link in the description and follow along with me. Look, my previously created dashboard consists of 9 blocks. I recommend planning the dashboard structure and block placement in advance, for example, by sketching them on a sheet of paper or in some editor. There can be a variety of different options, and depending on your preferences, the dashboard can look one way or another. Regarding this lesson, I will show you how this particular version of the dashboard is created. However, the provided information will be sufficient for you to later form it in whatever way you desire. Alright, we've settled on the block arrangement, which means it's time to create a new sheet in the Excel document. It is crucial to name each sheet to easily navigate the document and not get confused later on. Hold down the Control key to select multiple sheets at once. Using the Insert tab, I will insert a regular rectangle. It is from this shape that the blocks of my dashboard will be built, and to set the correct size, it's necessary to temporarily remove the display of unnecessary elements in the work window. In the View tab, I will hide the formula bar display. Then, I'll go to the File tab and choose Options. In the Advanced section, I will hide the scroll bars and sheet names. Alright, now in the upper right corner, I will hide the ribbon display. It's time to prepare the foundation for the dashboard. The presented shape is an independent object in the Excel program, and in this lesson, I will dedicate a lot of time to working with objects. There are several ways to move and resize objects. If you simply move an object by holding the left mouse button, it is obviously harder to accurately position it in the desired location. However, holding the Alt key allows you to snap the object to the cell borders, making this method the most convenient. And if you hold the Shift key, the object will move strictly horizontally or vertically. You can also use the arrow keys on your keyboard to move objects. So, I am starting to create the base for the dashboard. I will press the combination of Ctrl+1. In this menu, I will remove the shape fill and highlight the outline in bold red. Next, I will copy the shape. I will place it one layer above. It's important to hold the Alt key and ensure that the contours of the shapes match completely. Now, I want to divide the base into 3 blocks. Take a look at the sample. To do this, I will go to the shape size settings. The first block is ready. I will select it. Then press the combination of Ctrl-Shift-Alt and, while holding the left mouse button, move the object to the right. Thus, I added 2 more blocks. In this case, the Control key was used for copying the object, and the Shift and Alt keys were used for accurate horizontal placement with cell grid snapping when moving the shape. Similarly, I will add other blocks to the dashboard. To select multiple objects at once, hold down the Control key. Done. As you can see, there's nothing complicated about it. Now, I will group all these blocks into one group so they can be edited as a single object. To do this, I will select any of them and press the combination of Ctrl+A. All other objects are automatically selected. Now I'll move the cursor to one of the borders and right-click. Then choose the Group command. The peculiarity of working with a group of objects is that if you click on any object in the group once, the entire group is selected. And with a double click, a specific individual object is selected. You can also switch between them using the Tab key. So, I will scale these blocks a little more so that they occupy the entire sheet. I will hide the row and column indicators. The same goes for the cell grid. As for the dashboard size, it can be perfected using width and height settings. I remind you that your width and height values might be different from mine, so adjust according to your screen's parameters. Alright, a few more steps and the foundation for the dashboard will be ready. Position the cursor on any of the cells, hold down the Ctrl+A key combination, and proceed to the fill options. You can either choose or customize the desired color using the settings available in this window. However, if you know the code of a specific color, you can enter it in this field instead of searching. I will do just that. As for the line color, I will change it to and add a glow effect. If you find some mismatches with the lines, they can be manually corrected. Overall, I am satisfied. The foundation for the dashboard is fully ready, which means that hidden sheet elements can be made visible again as they will be useful for work. Most of the dashboard elements are formed based on pivot tables, so I will create another sheet and give it an appropriate name. I will switch to the sheet with the source data. At the moment, this entire data set is just a regular range of filled cells, and to make Excel recognize it as a table, a few simple steps are needed. I will select one of the filled cells and press the combination of Ctrl+A. Immediately after that, I press Ctrl+T. Since this data set has a header, it is necessary to set a check mark here, otherwise another header will automatically be created which I don't need. Good, now Excel recognizes this range of filled cells as a separate and unified object in the form of a table. This is important because a table has several advantages over a regular range of cells. You will learn more about this in one of the upcoming videos. Similarly, as with sheet names, I also advise you to name tables to avoid confusion and further work with the document. This is done in the Table Design tab. First, I want to create a chart that will illustrate sales data by month. I will select any cell in the table and click the pivot table icon in the Insert tab. I will definitely check this checkbox, otherwise, I won't be able to combine data from two different tables later on. Generally, I recommend adding tables to the data model, as it will expand your list of capabilities when working with pivot tables. Next, you need to specify where to place the pivot table, and as you remember, I already have a separate sheet prepared for this. Now I have an empty pivot table object, and I will create the report I need by distributing fields to specific areas. Move the month field to the rows area. The sales field to the values area. And the year field to the columns area. That's it, the report for the first chart is ready. I will give a name to this pivot table. Since there will be many pivot tables on this sheet, I will additionally specify its name to avoid confusion. To create a pivot chart, I will click on any cell in my report and select the Pivot Chart command in the Pivot Table Analyze tab. In the dialog window, find the appropriate option and click OK. The chart is added, but as you might notice, the sequence of months is incorrect. To fix this, I will return to the table and open the sorting options. In Excel, you need to set the correct sort order in the form of a template, which is located in this list. Some lists are already installed in the program by default, however, we can additionally create our own custom lists. Therefore, if you can't find a suitable list, create it yourself. I explain how this is done in my video dedicated to Excel's cell autofill function. Having set the parameters for sorting, I click OK. This time, the months are arranged in the correct order. Now I will transfer the chart to the dashboard by selecting the Cut command. Now I will work on the chart's design. First, I will remove unnecessary elements. I will place the legend at the bottom. I will remove the white background and the object's outline. I will make the text font white and bold. I will slightly reduce the space between the chart rows and change the color labels. The first block is almost ready, all that's left is to insert the title. Now I will demonstrate the use of slicers, which will customize this chart according to a specific query. You can add them through the Pivot Chart Analyze tab. In the dialog box, you need to select the criteria by which you want to filter data, for example, by years and regions. Slicers have appeared on the sheet with buttons for filtering. In this way, you can quickly compare monthly sales figures. The final appearance of slicers will be like this. I'll deal with the configuration and design of slicers a bit later, but for now, I'll remove them. The next chart will be similar to the previous one, with the main focus concentrated on regions. Instead of creating a new pivot table, I'll simply copy the one I already have and slightly change the placement of fields to generate a sales report by region. The table is ready, so we can proceed to create the chart. Everything is done in a similar way to the previous example. In the next chart, revenue will be displayed by quarters. To save space, I will reduce the quarter labels to 2 symbols. I will work with the gradient a bit to achieve a more interesting color scheme for this chart. Now I will create a pie chart that will show the sales shares by product subcategories. Note that there are quite a lot of product subcategories here, which makes it visually difficult to analyze the data presented in the chart. To solve this problem, I want to separately display the shares of only the 8 best subcategories, presenting all other subcategories in a summarized form. To do this, I will create another pivot table. To display the 8 best subcategories, I will go to the filter settings and select top 10. In the second field, I will set the number 8. Click OK. Great, but I need another table to form the final dataset for the chart creation. This time, instead of a pivot table, I'll use a regular cell range. I need to maintain the relationship between the tables, so I will create the first column as cell references. In the last cell of the column, I will write Others. I will also create references to the revenue cells. As you can see, the copying process was incorrect because, to create references to the cells of a pivot table containing numbers, it is necessary to specify the cell addresses. In the first row of the table, the revenue cell has the address F36. Therefore, after the equal sign, I will manually type this address. This is a specific feature of working with pivot tables. Thus, the revenue of the top 8 subcategories of products has been copied, and now only the total revenue of the remaining subcategories needs to be added. To do this, I will subtract the difference between the total rows of the 2 pivot tables. After the equal sign, I will click on the cell with the address C53. Then, I will add a minus sign and click on the cell F44. This is how formulas look when using data from pivot tables. I press the Enter key to get the result. This time, the chart will be created not from a pivot table but from a regular data range. As such, the chart will have fewer visual elements and will be easier to interpret due to the grouping of insignificant subcategories. And since my tables are interlinked, the data filtering will work without any issues. Let's check this. I will connect both reports to slicers. Yes, everything works correctly. This was just a test, so I will remove the slicers for now. Next, I will add the chart to the dashboard and edit it. Let's move on. Now I will create a set of charts for analyzing sales by product categories. In a separate column, I will calculate the sales shares. I will tweak the font slightly. I will insert a label and add the sales share for furniture in it. To do this, I will reference cell D59 in the formula bar. While holding down the Control key, I will select the label and the chart, and then group them together. To save time, I will copy this chart for the other categories. I will align these objects horizontally. Now I will work on each chart individually. Similarly, I will create charts to analyze sales by segments. To simplify the task, I will copy the previously created charts and replace the data in them. Note that I am trying to change the data source for a chart, but this option is unavailable. The issue is that I need to break the link between the chart and its current data source. To do this, I need to paste the chart into a new workbook and then bring it back. This way, the link will be severed, and I will be able to add new data for the chart. So, I will select this group of objects and execute the cut command. Then I will create a new workbook and paste the cut objects into it. Alright, as a final step, I will cut these charts and paste them back into my dashboard. I will close the new workbook since I no longer need it. Let's check. Excellent, this time I am able to change the data source for the pivot chart. Now, I just need to work on the formatting a bit. Done. In the bottom center block of the dashboard, I will display the ranking of cities by revenue. It will allow viewing both the best and worst performing results. Ideally, I could insert a standard Excel table here, but the issue is that such a table cannot be formatted as beautifully as in the given example since, unfortunately, the program's available tools do not enable gradient and transparency customization. Therefore, to achieve the desired result, I will need to spend a bit more time and use shapes instead of cells. So, to begin with, I will create a pivot table. I will keep only the 10 cities with the best sales results in the table and sort the revenue in descending order. Now, I will add shapes for the first row of the table. The first column will contain the row numbering. The second column will display the cities, so in the formula bar, I will add a reference to a cell from the pivot table. In the third column, I will specify a reference to the cell with the revenue. I will group these objects and make 9 copies. To quickly select the objects, you need to click the corresponding icon in the Home tab. I will align them and then ungroup the selected objects back. Now, I will fill all the shapes. Of course, I cannot autofill data inside the shapes, so I have to do it manually. Sometimes, I will speed up the video slightly so as not to waste your time. I will combine the columns into separate groups of objects so that I can format their styles independently. Let us continue. As the next step, I want to place a chart neatly next to the table. This chart will visually represent the revenue for each city. For it, I will create separate columns. I will enter an equals sign and type a formula. I will press the F4 key to make the range absolute and avoid reference shifts when copying the formula downward. I will convert the obtained values into percentage format. I will then perform another calculation nearby. After that, I will create the chart based on the obtained values. I will add a few more objects. These will act as toggles between the two reports. I will configure the toggles after I have created all the dashboard blocks. The next block will feature a chart indicating the percentage of the sales plan completion. It is time to use the second table with the raw data, which I showed you at the beginning of the lesson. The challenge is to filter the data from two different tables using the same slicers. To achieve this, I will convert the sales plan completion data into a table. I will name this table. If the name consists of several words, an underscore must be placed between them because using irregular space will result in an error in the program. Next, I will need the Power Pivot tab. If you do not have this tab, you can add it through the Developer menu. So, I will select a cell in this table and click the icon Add to Data Model. This way, I have added this table to the data model. Note that the first table is also present here, as at the beginning of the lesson, when creating the pivot table, I checked the box next to the corresponding parameter to include it in the data model. I will click the diagram view icon. In this window, I can set up relationships between the two tables, provided that they have matching fields. In this case, I am interested in the years and regions fields, as these are the ones I will use to filter the data on my dashboard. However, as you can see, when attempting to create a relationship between the tables, I encounter an error. The issue is that both tables have duplicate values. Therefore, my task is to create two intermediate tables that will have unique values for years and regions. To do this, I will select a cell in the first table, go to the Data tab, click on the corresponding icon, and then choose Close and Load to. In the dialog box, I will select the option Only Create Connection. Then, I click OK. I will do the same for the second table. Now, in the Data tab, I will create a query. In the opened window, I will choose the tables to merge. Here, I need to keep only the column that contains the years. I will highlight its header, right-click, and select the command Remove Other Columns. Then, I will right-click again and delete the duplicates. To avoid confusion when selecting a slicer, I will give the original name an asterisk at the end. Once that's done, I will load the data. I will be sure to check the box labeled Add this data to the data model. I will repeat the same process for the regions. Alright, now I return to the Power Pivot window. Thanks to the intermediate tables where duplicate data has been removed, I can easily configure the relationships between the tables. Based on the second table, I will create a pivot table. I will add slicers. For filtering fields, I will select them not from the main tables but from the intermediate ones. Now I can connect these slicers to the other reports as well. This way, I can simultaneously filter data from tables created from different data sources. As you can see, the charts adjust depending on the criteria I select. Similarly, the table built from the second data source is also filtered. Using the new pivot table, I will calculate the percentage of the sales plan completion. I will return to the dashboard and create a reference to the cell with the sales plan's completion status. Now, I want the text color in this cell to change depending on the level of plan completion. For this, I will need the conditional formatting option. I will create several rules. I will specify a reference to the highlighted cell and write a condition in the form of a formula for text color formatting. Thus, I have created a rule where the text color in this cell will automatically turn purple if the specified condition is met, that is, if the value in the cell is less than or equal to 20%. Now, I will create several more rules. You can view the created rules in the Manage Rules menu. Here, they can be edited or deleted. So, as you can see, depending on the level of the sales plan completion, the text color in the cell changes according to my specified rules. Next, I need to increase the font size and place the cell in the appropriate location. Look, when I change the cell sizes, the dashboard starts to shift, which is unacceptable for me. To fix this, I will select all the objects on this sheet. I will go to the settings and choose the option that ensures the objects remain fixed and do not respond to changes in cell sizes. Great! This time the objects stay in place, and I can adjust the cell sizes to suit my needs. Now, it's time to create a speedometer style chart. First, I need to prepare the source data for the chart. I won't comment much here, just watch and follow me. While creating the chart, you'll understand the purpose of all these values. Alright, the speedometer is ready. Now I will add 3 more elements to this block. The first will display the number of products sold. The second the total revenue. And the third the number of cities. I will create 3 pivot tables to get the respective metrics. A very important point: currently, the table shows the number of cities, including duplicate names. The result is incorrect, so I will go to the field settings and choose the option to display only unique items. This way, I determine the accurate sales coverage by cities. Now I will focus on customizing the appearance of slicers. In this menu, I will set the colors for the slicer buttons, which will be displayed when interacting with the mouse cursor, as well as when enabling or disabling filters. The slicer style is set, and they stand out with the colors I've chosen during interactions with the mouse cursor. Alright, it's time to return to the city ranking and create a toggle between reports. First, I will make a copy of my dashboard on a separate sheet. So, now I have two identical sheets with dashboards. Next, I will create a negative city ranking for the second dashboard. I will replace the city ranking data with negative values and set up links between the sheets. I'll speed up the video a little so as not to waste your time. That's it, the dashboard is fully ready, only the unnecessary elements need to be hidden. I will set up sheet protection to ensure that all objects remain static while only the slicers respond to clicks. To do this, I will click on any object and then press the Ctrl+A. Now, all dashboard objects are selected, and I can set common parameters for them. However, I need to exclude the slicers since these parameters do not apply to them. So, I will deselect them. To do this, I'll hold down the Control key and click on the slicers. For all other objects, I will select the locked parameter. As for the slicers, this parameter must be disabled. In the Review tab, I will click on the Protect Sheet icon. In this window, you can allow or prohibit specific actions on the sheet. I want the objects I protected, such as text and charts, to not respond to mouse cursor interactions, so I'll only leave the checkbox in the second option. Additionally, you can set a password here, which will prevent anyone from removing your sheet protection settings. From this moment on, I can no longer select or edit the charts. When I click on them now, nothing happens. The only thing available to me is filtering reports with the help of slicers and toggling the city ranking. I will do the same for the second dashboard. Please note that a blank area appears when I scroll down. To prevent this, I will restrict the scroll area. To do this, I will press the Alt plus F11 key combination. Double-click this workbook and manually type in a special code. You can follow along, just make sure that the correct sheet names are specified. In my case, these are Dashboard and Dashboard 2. If you've named your sheets differently, make sure to check this carefully. The next step is to save the Excel workbook in XLSM format. I'll open this file. Now, when I scroll the mouse wheel, my dashboard stays in place. This brings us to the end of the video. Give it a like if you found the tutorial helpful, and subscribe to the channel to avoid missing new videos. Also, remember that you can download the Excel file with the source data for creating the dashboard via the link in the description. I wish you success in learning. Goodbye.